Okay, we're going to do some review skills for Unit 1, some important things that you need to make sure you understand. Let's start with arrays. If you have a rather large array, doesn't even have to be super large, but even something like that, you wanted to know the fact or the number model that goes with that array. It is not wise to sit and count every dot. You might miscount, and you also are going to waste a lot of time. You're going to count down the side, and you see that there are 4 rows, and then you can count how many columns there are. There are 5. So I know that this is a 4 by 5 array. So the number model that goes with this should be 4 times 5 equals 20. I can count by 5s. If I'm not sure of that fact, I'm going to practice my facts for one, then I'm going to count. I can count 5, 10, 15, 20. And I can see that 4 times 5 is 20. I also know that the fact triangle that goes with this array, I already know that the product of 4 times 5 is 20, but I can also, that gives me lots of other pieces of information. I know the facts that go with that could be 20 divided by 5 equals 4. I could also write that differently. I could write 5, which is another fact in the fact family, equals 20 divided by 4. Pay attention to the equal sign. It doesn't matter if 20 divided by 4 goes on this side or this side. It matters that both of the things on each side of the equal sign are equal. So when you're doing arrays, count down the side first. That gives you your first number in the number model. Count across the top. That gives you your second. And then multiply those numbers rather than counting all of the dots. Another rule I want you to understand, or another thing that you need to understand for Unit 1 is divisibility. If a number is divisible by another number, that means that it can be divided evenly by that number. So what are some basic rules of divisibility? If I want to know if a number is divisible by 3, what can I do? Well, we know a shortcut that we can do is by adding the digits together, then dividing that number, which is a lot smaller, by 3, and see if it can be divided evenly. So let's say I've got the number 246, and I want to know if 246 can be divided evenly by 3. I'm not going to do long division. I'm not going to use my calculator or try to do something crazy counting by 3s to 246. Instead, I'm going to add the digits, 2 plus 4 plus 6, and I get 12. Then I look at this number. Is 12 divisible by 3? Can I divide 12 by 3 evenly? Yes, I can. So, yes, 243 is divisible by 3. So then what's another number? Something that's pretty basic, we know, is 2. If something is divisible by 2, it has to be an even number, ending in 0, 2, 4, 6, or 8. So the number 246 is divisible by 2 because it's an even number. I look at the ones place, I see the 6, and that tells me that it's even. So yes, 246 can be divided evenly by 2. If I want to know if something is divisible by 6, then I'm going to need to know if it is divisible by 2 and 3. So I can't just look at a number and know if it's divisible by 6. I have to do 2 different tests. First, the simplest one, is it an even number? Is it divisible by 2? If the answer is no, you know that 6 is not going to go into that number evenly. You can just stop there. But if the answer is yes, like it is in this number, 246, I can say 6 might be a factor of 246, or 246 might be divisible by 6, but I'm not sure yet because that's only half the test. Now I have to decide if it's divisible by 3. Is 246 divisible by 3? Yes, it is. We determined that already. So I can cross out the might and I can say, yes, 246 is divisible by 6 because it is divisible by both 2 and 3. The last kind of shortcut rule I'm going to give you is 9. You're going to do the same thing with 9 that you do with 3. So I'm going to do 9. The rule is add the digits, and if that sum is divisible by 9, then yes, that number is divisible by 9. So let's see, in the number 246, I did 2 plus 4 plus 6, just like I did up here, and I get 12. Is 12 divisible by 9? Can I divide 12 into 9, or by 9 evenly? No, I cannot. So 246 is not divisible by 9. You can use the rule of thumb for 5 and 10, that a number has to end in, for 5, a number has to end in 5 or 0. So 246 is not divisible by 5 because it does not end in a 0 or a 5. Does not have 0 or 5 in the ones place. The rule of thumb for 10 is a number has to end in 0 because it's a multiple of 10. So we talked about divisibility. You need to also understand prime and composite numbers, which has to do with divisibility. If a number is prime, the only two factors are 1 and the number. For example, the number 7 only has two factors, 1 and 7. So this number is prime. A number is composite if it has more factors than just 1 and the number. For example, 12. I know that 12 is composite because the factors are 1 and 12, 2 and 6, and 3 and 4. So this number is composite because it has more than just two factors. There are other numbers that are composite. There's lots of numbers, infinite numbers that are composite. Let's give a few more examples. 8 is a composite number because the factors are 1, 2, 4, and 8. 9 is a composite number because the factors are 1, 3, and 9. Other prime numbers, 11 is another prime number because the only two factors are 1 and 11. Those are the only things I can multiply together to get those numbers. That's what makes a number prime or composite. So with this said, how do I find these factors? What's a good way to do that? Or you can make a factor rainbow. Factor rainbow would be, I'm going to do 1 for 9. I know that I multiply 1 times 9, so I'm going to draw one hump of the rainbow to get that. I'm going to test 2. 2 times nothing is 9. 3. Oh, 3 times 3 is 9. I can stop right there because I've already repeated a number. Let's try something a little bigger. How about 24? I know that the first thing I multiply is 1 times 24. See, I'm spreading it out so I have room for all the other factors in my rainbow. 1 times 24. This is an even number, so I know that 2 is a factor. 2 times 12. 3. 3 times... I can go through my 3 facts and I find that 3 times 8 is 24. Make that rainbow hump. I know another factor is 4 because 4, and I'm getting a little squishy here, 4 times 6 is 24. I know that 5 is not a factor because this number does not have a 0 or a 5 in the ones place. So I can stop right there because then I start repeating factors. So this is how I come up with a factor rainbow. This gives me all the factors in a number. Another thing that we sometimes come up with is a factor tree that we can use to break down a number. Okay, these are different things. So this is a rainbow. Now let's take a look at a factor tree. Just divide that off. We're going to make a factor tree. We're going to come up with a string of factors that basically represents a number. So let's start with the number 24. I can pick any two factors I want that multiply together to get 24. Well, I've got plenty over here. I'm going to use 3 and 8. 3 times 8 is 24. But those are not prime numbers. In a factor tree, I have to continue to break the numbers down until I get a prime, or everything prime. So 3 is a prime, so I'm going to bring that down a level. I'm just going to rewrite it. 8 is not a prime number, so I need to break that down into two different things. Well, I know that 4 times 2 equals 8, so I'm going to write those numbers. I'm still not all the way prime because 4 is not a prime number, so I'm going to bring everything down again. 2 times 2 equals 4. And now I've got all prime numbers at the bottom. All of these numbers at the bottom are our factor string. Three times 2 times 2 times 2 equals 24. You don't believe me? Well, let's make sure. 3 times 2 is 6. 6 times 2 is 12. 12 times 2 is 24. What do you know? It worked. Another way that you can write this, you can shorten because there's 3 2's and you're multiplying the same number 3 times. I gotta leave the 3 times 2 to the 3rd power, or 2 cubed, because there are 3 of them. So another way to write the number 24 is by writing 3 times 2 cubed, which is the factor string for 24. No matter what numbers I choose to do first, I'm going to come up with the same factor string. Might not be in the right order or the same order, but it's going to be the same factor tree. So let's take a look at that. Let's try another example just so you can see it is going to be the same thing. Okay, so let's do 24 again, but I'm going to use different factors this time. This time I'm going to do 12 and 2. 12 times 2 is 24. 2 is prime, I'm going to bring it down. 12, I can do 2 times 6. 2 is prime. 6 is not prime, so I'm going to multiply 2 times 3, and I'm going to bring down my other prime number. I've got my factor string because all of these numbers are prime. 2 times 2 times 3 times 2. I've got the same numbers, they're just in a different order. Because I'm multiplying, it doesn't matter. And I can shuffle those around, and I'm going to write 2 cubed times 3 is the factor string that represents 24. This is an expression, another word for a string of operations that does not have an equal sign. Expression. An expression represents a number without using an equal sign. Okay, so that's the next thing I want to talk about. The expression 4 times 8, I know that the number that represents is 32. Down here, something that we've used to represent 24, this expression, this is exponential notation. Why would it be called exponential notation? Well, because it has an exponent in it. Okay, so the next thing we're going to look at is a chart of numbers that has exponents. I'd also like to show you how that compares to standard notation and other ways that we can represent numbers. So let's take a minute and look at that. Okay, the next thing we're going to focus on is exponential notation, what that means. Okay, first I'm going to write an expression. Remember, an expression does not have an equal sign, so I'm going to do 3 times 3 times 3. 3 times 3 times 3, written in exponential notation, is 3 to the 3rd power, because there are 1, 2, 3 threes. Written in standard notation means just write the number. What does 3 cubed mean? What does 3 times 3 times 3 mean? Well, let's do it. 3 times 3 is 9. 9 times 3 is 27. So the exponential notation means written with an exponent. The expression is a string of factors, and standard notation means just write the number. And the way that you're going to come up with this, how do I write something in exponential notation for the number 27, is doing a factor tree, just like we did a minute ago. If you wanted to do a factor tree, that's going to help you come up with the string of factors. So for the number 27, let's do that so you can see that. I'm going to come up with 3 times 9 equals 27. Okay, so 3 is prime, so I'm going to bring that down. 9 is not prime, so I'm going to come up with more factors. then I get all primes, so the factor string is 3 times 3 times 3. That's an expression that I can condense into exponential notation that represents the number 27. Let's do another one. Let's do, okay, we have a string of numbers here, an expression, 2 times 2 times 2 times 2. Well, how many 2's do I have there? I have 4 2's. So 2 is the large number, okay? The exponent is going to be 4 because that's how many of them I have. Well, what is the standard notation? I've got to figure it out. 2 times 2 is going to be 4, times 2 is 8, times 2 is 16. So the standard notation is 16. Let's check our math, or let's make sure that we've done this correctly. Let's do a factor tree, kind of working backwards to check our work. So 2 factors of 16 are 4 and 4. 4 times 4 is 16. Neither of those are prime, so I'm going to break them down again. And I get 2, and 2 is 4, and 2 and 2 is 4 again. So here I have my factor string, 2 times 2 times 2 times 2. Hey, there it is. So 2 times 2 times 2 times 2 is 2 to the 4th power, which is the number 16. All of it makes so much sense. Just break it all down. Make sure you understand your terms and what each of them mean. And that's going to really help you to be able to build on these skills the whole rest of the year. So keep practicing, keep working, and don't forget to ask questions when you have questions. You guys can do it.